Welcome to the second video tutorial of the Risk Data Library Analytical Tools, a collection of Python notebooks aimed at producing subnational disaster risk assessment for a range of natural hazards. Here we'll focus on the geospatial analysis of risk from floods of different origins upon both population and exposed assets. We are looking to produce quantitative exposure and impact metrics. These are calculated at the granular level and then helpfully summarized across subnational units. Now, if you do not have the tool properly set up already, I must kindly urge you to return to the first tutorial, which offers guidance on installation. Before we begin, a few words on the input data. The notebook is meant to work with the Fathom 3 datasets, but it can be adapted to work with other compatible flood models as well. A few demo datasets are provided in the code-based data folder covering Jamaica, Philippines, and Tunisia. However, for the sake of completeness, I will also show you how to add more flood hazard data from the Fathom collection. In the tool main interface, find the flood analysis option right on top. Before we dive in, however, note the presence of a pre-processing utility. Explore it without fear. Let's imagine you have previously downloaded the Fathom 3 fluvial undefended dataset for a country of interest from the World Bank repository. The downloaded folder contains multiple GeoTIFF tiles that needs to be mosaiced together in order to properly work with our tool. To do so, run the code cell in the notebook and check the output. Point to the folder that contains the subfolders and click Process Tile. You can enable the checkbox to delete the original data. It should be rather quick. And now the folder should show a bunch of TIFF files named after the original folders. These are the files we need in the tool, so move those in your data directory. All is ready now. Go back to the main interface and open the Flood Analysis tool. From the top bar, click Run All Cells. A visual interface will appear that is remarkably intuitive. In fact, its usability has been thoroughly tested across humans, great apes, and even a cockatoo, with overwhelmingly positive results in all cases. But let me explain it anyway. The menu on the left allows you to select the input and configure the type of analysis. First, pick a country and the administrative level at which to summarize our results. The tool will retrieve boundaries from the World Bank Geo server. Should you wish to use custom boundaries, simply specify a vector dataset, taking care to define the ID and name attributes that will be used for aggregation. Next, move to the Hazard tab. Here, you must select the type of flood you wish to investigate. In this instance, we shall proceed with fluvial undefended. You'll also need to set a minimum hazard threshold. 10 centimeters is generally a sound, conservative choice. Before moving on, remember to select the reference period represented by the data. 2020 refers to the historical baseline. The menu allows to select which return period scenarios are to be considered. Each represents a different hazard intensity in relation to occurrence probability. It is best to include all available scenarios when measuring risk. Now proceed to the Exposure tab. 3 categories are here available: population, built-up, and agriculture. Each is represented by a global datasets at 90-meter resolution. You can select any combination of the 3, so we might as well make use of all of them. Custom input is also supported, provided it is supplied as a GeoTIFF raster in the WGS84 projection. Finally, the Vulnerability tab allows you to determine the type of analysis to be conducted. The function approach enables the calculation of a proper risk index, namely the expected annual impact, or EAI. The tool comes equipped with damage functions, which translate hazard intensity into an impact factor applied to exposed assets. These curves are based on global studies, yet have been calibrated to reflect macro-regional conditions. Alternatively, if you prefer a classification of exposure levels across various hazard thresholds, select the second option. Here, you'll specify the thresholds of interest, for instance 50, 100 and 150 centimeters. For this example, however, we shall proceed with the first method, using an impact function. And now, the moment has arrived. Enable the results preview and export options as needed. Then, initiate the analysis by pressing the big red button. Splendid! Was it quick? I believe it was. Let's have a look at the results preview. The map shows the EAI output at boundary level, which should have also appeared in your output folder as GeoPackage file. That can be loaded in GIS software to produce better-looking maps. Together with the geodata, you'll find an Excel file summarizing the results and the expected annual impact charts for all selected categories. This concludes the second tutorial of the Risk Data Library Analytical Tools covering standard flood risk screening. Stay tuned for the next tutorial, where we'll look into tropical cyclone risk. Hold fast and never cease to marvel at the wonders of nature.